Alright guys, welcome to Daily Problems 4. This is a mixed set, so calculators allowed on the free response and no calculators allowed on multiple choice. Alright, so let's take a look at problem number 1. Let R be the region enclosed by the graphs of y equals 2 natural log of x, y equals x over 2, x equals 2, and x equals 8. Alright, so let's draw that region. Alright, so we have y equals 2 natural log of x. So natural log of x and anything multiplied by it is going to look something sort of like, oopsie, try that again, something like that. Okay, and x equals, y equals x over 2 is going to be some kind of line. Right. Headed out like this roughly, and then x equals 2 is a vertical line, probably somewhere like that, and x equals 8 is another vertical line, probably somewhere out like this. Okay. Ultimately this is a calculator problem, so you can feel free to plug this into your calculator if you're not sure what it looks like. Okay. Set up find the area of R. Okay, so we're looking to find the area, which means we're going to integrate, as always. And we're integrating from, they gave us nice bounds, right, from 2 to 8, so we don't even have to try and find anything here. And the area means we go from the top curve to the bottom curve. And so that should be pretty clear for us. 2 natural log of x is the top curve, minus x over 2 is the bottom curve, dx. Right? So pretty straightforward problem here, and we're going to plug this into our calculators. Whoops, so this is our problem page here. Okay, so let's take a look at what we get here. Oops. So we're going to go math 9 for FNINT. Oops. Yeah, we're just going to move this here. Okay. And we're going to have the, let's see, 2 natural log of x, close that parenthesis, minus x over 2, and there's our function, comma x, comma, and then we're going from 2 to 8. Close the parenthesis, and that's it. So 3.498. Okay, it's nothing to that one. Yeah, so 3.498. Okay. Okay, part B. Set up, but do not integrate, an integral expression in terms of a single variable for the volume of the solid generated when R is revolved about the x-axis. Okay. And so just so we're clear, this is R right here. And we're going to revolve that about the x-axis, which is right here. Okay. So this is going to be, we're revolving about the x-axis, and we're integrating in x, and so integrating in x, revolving around x, they match. So we're going to use disks and washers. Okay? And so this is going to be a washer problem because it's not right up against the x-axis. So we're going to have an outer radius and an inner radius. And the outer radius is going from here to here. The inner radius is going from here to here. And so we're going to integrate. So we have pi on the outside. Integral, still integral from 2 to 8, because those are our bounds in x. And then we're going to take, oops, hang on, our outer radius. Outer radius went from here down. And so our outer radius is going to be 2 natural log of x. Oops. And then that outer radius gets squared. Minus, and then we have our inner radius, and our inner radius was the line, so that's going to be x over 2, and that gets squared, dx. And we don't have to do anything with it, we don't even have to integrate, so that's our final answer. And then the final question says, set up but do not integrate an integral expression in terms of a single variable for the volume of the solid generated when r is revolved about the line x equals -1. Okay, let's move this whole thing over. Okay. And I'm going to do that one in red. So, let's see. So, part B, the picture was in green. Part C, the picture will be in red. So we're going to revolve around a line that's out here, right? So we're revolving around this line. So now, last time it was the x-axis. This time it's something, it's not the y-axis, but it's parallel to the y-axis. We were integrating in x, but it's parallel to the y. So now it doesn't match. And if it doesn't match, we use shells, right? So when we're using shells, we're going to say 2 pi, still integrating in x, so our bounds are still in x. And then we have 2 pieces for shells. We have our radius, and our radius goes y-axis to the line, right? So the y-axis to the line, so we're going to say x minus the line, and the line was -1, so x plus 1. And then the height, and the height is just the height of our function. And the height of the function was 2 natural log of x minus x over 2 dx. And that's it. So with shells, you have a radius, and the radius goes from the axis to the line, and then the height of your area, and that's it. Okay. Now we could do this if we wanted to do this using discs and washers if we prefer, but then we'd have to switch everything over and do it in y, because you always have to match. If we did this in discs and washers, so I'll do that in a different color, I'll do that in blue. So if we use discs and washers, now we'd have to say, okay, well we're going all the way out to that red line, so we have to have an outer radius and an inner radius, right? But now we have to be careful because we'd have to go, and this picture is not exactly drawn, I believe they meet here, actually. You'd have to look at the picture on your graphing calculator, but I'm pretty sure they meet here. And so then we'd have to go, well, okay, the outer one is the line, right? So we'd go from the line to this curve. Okay, and so then we'd have pi, and then we'd say from the line, but the line we'd have to change it into y, so we'd have 2y equals x. And so we go from the line to that, which is y plus 1. And then we'd have to go from the curve to that, and that gets squared. And the curve to that guy is going to be something else. But then we'd have to be careful because sometimes we're not actually going from the line or the curve. Sometimes we're going from this guy. It gets very messy. Okay, so yeah, don't do this. Shells. Shells make our lives happy. Okay, because you don't want to have to decide, well, am I going from the line? Am I going from the line to the curve, or am I going from the line to this, or am I going from this funny line to this, or am I going from the curve to this? And then you have to have 3 separate integrals, and we don't want to do that. Okay, don't do this. Learn to love shells. Really. Okay. Question 2. The regions R1 and R2 shown below are enclosed by the graphs of f of x equals x squared and g of x equals 2 to the x. Find the x and y coordinates of the 3 points of intersection of the graphs of f and g. Okay, so this is kind of a funny looking graph here. And we can kind of see this blue line here is x squared and the purple one is 2 to the x. And they intersect here, here, and here. Now we can see if we look down, we can almost see, it almost looks like it would be at 4 and at 2. And you can confirm that if I say 4 squared, that gives me 16, and 2 to the 4th gives me 16. So we can say that this point here, I'm going to call that point C. Okay. So if I call this one point C, this one will be point B, and this one will be point A. Right? So point C, x equals 4, and y equals 16. So that seems to work. And then if I plug in 2 squared is 4, and 2 squared is 4. So 2 seems to work as well, with y being 4. But if I look over here, this is clearly some kind of funny looking decimal. It's not 1, right? 1 squared is 1, 2 to the 1st is 2. So 1 isn't what it is. It's some kind of funny decimal. We're going to have to find that. Okay? All right, that's not so bad. So we're going to go to our handy calculator, and we're going to plug in x squared, and I'm going to say minus 2 to the x, and I want to know where is that going to be equal to 0. And so I'm going to change my window to be I want to see we could see that it was around -1, so I'm going to say -1 to 0, right? And I'm going to make this, I only want to see from -1 to 1, because I just want to see right around the x-axis, right? And so we graph, and we can see that's the 0 we care about right there, right? So we're going to go second, calculate, and hopefully it's going to like me someday. There we go. And we want to calculate the 0, so I'm going to say 2. And we need a left bound and a right bound. So we're going to trudge along here. We want to make sure we're on the left side of it at some point. And it's moving slowly but surely. The computer apparently is okay. And so now we can see that y is positive, so that means it must be on the left side, right? Okay, so then we hit enter, and we're going to move it back along, and it's hard to tell, but I can see that y has changed from positive to negative, so now it must be on the right-hand side. And then I'm going to hit enter, and then it's asking for a guess. It doesn't matter what you choose for a guess, so just hit enter again. And now I can see that y equals 0. That's perfect. So I'm going to say -0.766667 is a good choice, right? Or for us, 3 decimal places, -0.767. Now, the next thing I'm going to do is I'm going to quit this, and then I'm going to store that value for later use. So I'm going to say x, and then I'm going to press this STO button, and I'm going to store that as A for later use. Okay? And then the next thing I'm going to do is, they've asked us for x and y values, right? So I'm going to say A, and then I'm going to square that, and there's my y value. So 0.5877747 blah blah blah, right? Or in other words, for us, 0.588. Okay? So there's both of our values. And I can go back and write those in. So I have negative 0.767 and 0.588. Okay, that's part A. All right, so erasing that there. Okay, A, B, C. Okay. Without using absolute value, set up an expression involving one or more integrals that gives the total area enclosed by the graphs of f and g. Do not evaluate. Okay. So in other words, find the areas of R1 and R2. All right. So, without using absolute value, which makes our lives substantially more complicated. So looking at this, I can see that for R1, my area going from top to bottom, making tiny little arrows here, is going to be the integral. I'm going from A to B, but we can't just write A to B, because if I write A to B, they're not sure if I'm using the X value or the Y value. So we have to make sure that we don't just put that. So I'm going to say from negative 0.767 to 0.58, no, sorry about that, not that. So going from the X values, which means from negative 0.0676 to 2, right, which is the B X value. And then the top function is the purple one, and the purple one was 2 to the X, down to the blue one, which is X squared dx. And then I'm going to do R2, right? So this one is R1. And then R2 is going to go from 2 up to 4, right? And that's going to be the blue function, which is X squared, minus the purple function, which is 2 to the X, dx. And that's it. All right, and then part C, so this was R2. And then part C, it says, without using absolute value, set up an expression involving one or more integrals that gives the volume of the solid generated by revolving the region R1 about the line y equals 5. So about this line right here. Roughly. Do not evaluate. Okay, so now we want to go around this line. This is a line parallel to the x-axis, and we're integrating an x, so we're going to use disks and washers. And then we need the outer radius, which is going to involve the blue function, minus the inner radius, which is going to involve the purple function. Okay, so here we go. Pi on the outside, since it's disks, and we're using, since we're integrating an x, we're going to use the x bounds for a and b. So negative 0.767 to 2, and then the outer radius is the bigger radius is the blue function. That's x squared, but we're still going from the top to the bottom. The top is 5, so we're going to say 5 minus the blue function, x squared. And then it's the outer radius squared minus the inner radius squared. And the inner radius, we're still starting at 5, minus the purple function, 2 to the x. And then that has to get squared as well, dx. Kind of a crazy problem here, but hopefully that made some sense. Okay? All right, question 3. If f of x equals secant x plus cosecant x, let's write that down here so that we can see it nice and large, then f prime of x equals, well, this is a pretty straightforward problem here. Nothing to it but to do it. So secant x, we take the derivative, and secant x is just, or the derivative of secant x is just secant x tangent x. And then the derivative of cosecant x is negative cosecant x cotangent x. Okay? So this is mostly a memorization thing, and you got to have these derivatives memorized. So we can see that that one is E. Okay? So nothing to this one, just some memorization. So hopefully you got these memorized by now. Question 4. If f of x equals cosine squared x, then f double prime of pi equals, alright, so we're starting with cosine squared x. So then f prime of x will be, we have some chain rule, so this is kind of like having cosine x squared, right? So we bring the 2 down, keep the inside the same, and then we take the derivative of the inside. The inside is cosine x, so the derivative will be negative sine x. Okay? So we put it all together and we get negative 2, in whatever order you like here. I like sine x first, don't know why, I just do. And then from here, we can make this the second derivative, and we've got 2 pieces here, right? We can leave the negative 2 out front, and then this is the first function, and this is the second function, right? So I'm going to have negative 2 out front, and then we have derivative of the first is cosine x, times the second is cosine x, plus the first is sine x, derivative of the second is negative sine x, and then we put it all together, negative 2, and this will be cosine squared minus sine squared. Okay. And then we can plug in pi. Still have negative 2 out front. And then we have cosine squared of pi minus sine squared of pi. Not sure why this one got parentheses and that one didn't. Cosine of pi is going to be negative 1. And then that gets squared, minus sine of pi is 0, and that gets squared. Negative 1 squared is 1, minus 0 is still 1. So negative 2 times 1 is negative 2, better known as A. Incidentally, just as a quick side note, we can actually make our lives easier if you happen to remember that 2 sine x cosine x is the same thing as sine of 2x with an 8, and of course this negative stays there. And so then f double prime of x is just, this is another chain rule, and you get negative derivative of sine x is cosine of 2x. And then derivative of the inside is just 2. So then we plug in pi, and you get f double prime of pi is negative 2 cosine of 2 pi. And cosine of 2 pi is 1. So you get negative 2 times 1 is negative 2. So if you remember some of your trig identities, you can make your life a lot easier. But this trig identity right here is not a required trig identity on the AP exam, so I won't make you memorize that one. But if you happen to memorize that one, it might make your life a little bit easier than trying to do all of this extra stuff. Okay? So just a thought, pointing it out. All right, and number 5. An equation of the line normal to the graph of y equals the square root of 3x squared plus 2x at 2, 4 is. All right, here we go. So if y equals the square root of 3x squared plus 2x, then y prime equals, and so derivative of square root, right? You can make this equal to 3x squared plus 2x to the 1/2. And then the 1/2 comes down, blah, 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 and you end up with 1 over 2 root 3x squared plus 2x, right? One of those good things to have kind of memorized. And then you have chain rule, which you multiply over there, and then it moves up to the top, and we get 6x plus 2. All right. So that gives us the derivative. Now we need the derivative at this point, right? So y prime of 2 is going to be, well, 6 times 2 is 12 plus 2 over 2 times the square root of 3 times 2 squared is 12 plus 2 times 2 is 4. 12 plus 2 is 14 over 12 plus 4 is 16. Square root of 16 is 4. 2 times 4 is 8. It's looking like 7/4. Okay. But here, let's make sure that we remember, they didn't ask us for the equation of the tangent line, which is what we're used to seeing. They asked us for the equation of the normal line. So the slope of the normal line, right? The normal line is the line perpendicular to the tangent line. So if it's going to be perpendicular to the tangent line, we're going to take this 7/4, we're going to flip it over and make it negative. So we're going to have negative 4/7. Not so bad, okay? And so let's make an equation of the line. All right, we can do that. And so we know that the point is 2, 4, right? 0.24. All right, so we're going to get y minus 4 equals negative 4/7 x minus 2. We can circle it and be done, right? Not quite. This is multiple choice. So what do? Well, the first thing I would do is notice how none of these guys have fractions in them. So I would get rid of the fraction first, right? Kill the fraction. So to kill the fraction, I'm going to multiply the whole thing by 7, right? Because that's going to get rid of the fraction. So that's going to give me 7y minus 28 equals negative 4 x minus 2. All right, I like it. And notice none of these have parentheses in them, so I'm going to distribute, and that's going to give me negative 4x plus 8. Okay? And then the next thing I'm going to notice is that in all of these guys, all of the variables are on the same side, and all of the numbers are on the other side. Okay? So I'm going to move some stuff around. I'm going to add 4x, and I'm going to add 28, and that's going to go away, and that's going to go away. I'm going to have 4x plus 7y equals 28 plus 8, I think is 36. And that matches this guy. Alright. So sometimes looking at your answers gives you a clue of what you need to do next. And that's it. Alright. See you guys on Thursday.